the programmer world, you spend hours upon hours every day trying to make things less complicated. But I need this to be more complicated. So that's where this other one came from. Other one came in from. So you can ignore this thing on the bottom. This is some like an example thing of how pathing would work. But so you can see here we have a lot more gate connections now. Every system can have up to 4 connections, just because that's the arbitrary number I picked is 4. So every system here will have at least 4 active connections, or at most 4 active connections. I mean, but I'll have at least 1. There will be some systems that actually have more than 4 connections, though, because one-way gates don't count as an active connection. So in the system they're in, they do. To the system they're going to, they don't. So let me see if I can find one where this is like the case. Here, this one, 24. 24 has 4 active connections to it, but it also has this 5th one-way connection from 29. Since this is a one-way connection, there's no actual physical gate in 24 that goes back to 29, so that means there's only 4 gates here, not 5. Now there is 4 gates here. It just happens that one of the gates just goes one way and doesn't come back to there, but still counts as a gate in 29. Let me go and get rid of this. No, not that. Damn, which one is it? Which one of you are you? There, this one. And so we have this more complex system that I can then look at and say, okay, this is something more like what's going to be generated by the code. We can use this to kind of model what should happen. So let's just kind of go over like what would happen here exactly. So it's the basic same premise as with the other graphic as far as how the trade regions are created. You get a certain number of jumps depending on the planet type, and then those jumps inform how far out you can trade with, how far out you can trade to. So, like for example, here we have this example here where your planet is in system 1. So over here, in this case, it's a 1, 2, 3. That's a 2. So it's a 2, 4. So the planet that we're looking at here is a 1, 2, 3, 4. So it's a type 3 planet. So it has 4 jumps. It's possible of doing a 4 jump thing. And we're looking at System 6 as the target system that we're using to create trade routes with. So this is another thing. So what we have to do now is when we decide what system we're going to start at to process the trade region, we have to figure out, okay, what system are we looking at to create a trade route to? So from the planet in this system to which system are we creating a trade route? So we're in System 1, a planet in System 1, and we're creating a trade route from System 1 to System 6. And that's basically what this is telling you here. Now, all these are the different paths that will lead to System 6 through other systems. So, and actually, these aren't valid. I realized that after the fact, because Gate 3 is a one-way gate, and I'm not going to have trade routes being created through one-way gates automatically. Maybe there'll be some way that you can make one yourself that way, but the game won't generate them that way. So basically what this is saying is that along this various chain of systems, you can find a way to plot to System 6 using these other two. So for example, you can go to 1, from System 1 to 2 to 4 to then to 6. You can go from 1 to 2 to 3 to 4 to 6. Or you can go from 1 to 4 to 6. And those are the only ways you can get to System 6 without repeating stuff. Now, you might say, okay, well, what about 1 to 4, 4 to 2, 2 to 3, 3 to 4, 4 to 6? Well, I've decided that trade paths are not going to cross the stream, so to speak. We're not going to go through the same system twice. You can only go through each system once. So, in that case, you still wouldn't be able to get there. So you can go, well, 1, 4, see, 1, 2, 3, 4. So I guess you could actually go from 1, 4, 3 to 5, 6. Let me go and add that in. So that's one not in here. 1, 4, 3, 5, 6. And you can go 1, 2, 4. So 1, 2, 4. 1, 2, 3, 4. Okay. Got to count correctly here. So as you can see, if you go to 1, from 1 to 4 to 3 to 5 to 6, you can go, but you can't go this way, and you can't go back into it or anything like that. So with those limitations and not being able to use one-way or inactive gates, which are these gray ones, like that says up there, these are your only valid trade routes from System 1 to System 6. Now, I mean, that seems fairly innocuous, and, you know, when I was writing this out, I was like, oh, this will be easy to do. Not so. Very not so. So, let me go ahead and pull this out of here because it gets really annoying to read this green text in this format here. So, I'm just going to grab all this, and yes, this is why I was saying, like, you wouldn't believe how just freaking complicated this crap is. Let's throw it into a blank document here. So, alright. Then what I decided was I was going to go ahead and go through and figure out exactly how the code should process this. Because what this does not tell you is all the times it tried to create a path and failed for whatever reason. Maybe because it was trying to go back into a system it already went through, or maybe because there weren't enough jumps to go to that system, or just because the routes it was following, the systems it was using, didn't lead to System 6. So, like, for example, the game doesn't know that 1 and 4 and 6 are really connected that way. It just knows that you have systems 1, 4, and 6, and they have all these gates in them. And you have to iterate through all those gates to figure out if they're connected. So, for example, here's one like that wouldn't reach System 6. So you go from 1 to 4, from 4 to 3, from 3 to 5. Now in 5 you can go to 6 and get there like we have here, but you also have these other two gates, 9 and 7. So you go to 9, there's no connection to 6 from 9, and we don't have any connection there from 7. Now here's the other thing. Well, let's say that we are going 1, 4, 5, 9. So this is 1, 2, 3. So at System 9, we are now on jump 3, which means we have another jump we can do. Which means we then have to progress from 9 to 17, 13, and 12. Now, here in 13 and 17, there's no connection to 6. However, in 12, there's a connection to 6, but it fails because that would be a 5th jump. And the planet, since it only has 4 jumps available, it can't actually make that trade route because it's invalid for that particular planet. Now, if that planet had 5 jumps, it'd be able to make that jump, and then we would have a trade route from 1 to 4. So 1, 4, 5, 1, 4, 5, 9, 12, 6 would be that jump, that trade route. And again, up here, we also have to then check these two because we're checking all the gates, so those fail. Now, that's what was missing from this bit, and that's what I kind of was like was just not clicking for some reason. So when I decided, okay, let's make sure that I'm not blowing smoke up my own arse with this. And I went through and said, okay, let's just progress through how maybe the code should look at this and how it should process it. And that's how this monstrosity of a thing came to be. So this is literally how the code will process this whole thing. And I'm showing you this because I don't actually have the code at a working state right now, and I'm not going to by tomorrow. I'm actually stopping working on it now so I can finish the audio and maybe get something else done on maybe the mod tool, or maybe gets something showable for the UI, but I don't think I will have anything ready for the UI by tomorrow. But so here's how this works. So you have the system that you're currently at. So we're examining System 1. That's the starting point, and we're saying that in this system where we have a planet that is a Type 3, so it has 4 jumps available for trading. So then we have to process all the jumps and figure out all the systems this planet can trade with. So on the first iteration of this loop that we're going through, we're going to say, okay, we need to find a... well, in the first iteration, we're going to create a trade route to itself so that it can essentially trade with planets within its own system. Then on the second time through, we're going to say, okay, at this point now, we are going to start looking at other systems. So we go through the gates are at System 1, and we say, okay, is this gate destination, which is system 2, in our trade route map yet? If it isn't, then we set system 2 as the target. Once it's the target, then we send the code to another loop that then goes through every system methodically and tries to find different connections within that 4 jump limit to get to system 2. So let's bring this up again, because this kind of really helps de-crazify what this craziness here. But so system 1 has a connection to system 2 because there's a gate to system 2 there. So we're creating our first trade route there by using this trade lane from, let's call it 1-2. And then we're creating that, we're putting it into a map down here. The tabbing is kind of off for some reason. So I have a map now instead of I was using a list of strings before because it wasn't that complicated, or wasn't set up the way it was going to be eventually. So it was just like kind of tracking things, and so I could see if it was actually creating the connections correctly. This is taking it a step further. So we have our system 2, which is our target system, the system that it's looking at as a trading partner. And then the value for that key is going to be a vector of trade routes. So a trade route is just basically an object that I have that will contain a start system and an end system, system 1, system 2. And it will have a vector of trade paths, trade lanes, which are going to be just the same kind of thing as trade routes are, but it's going to have the starting system, ending system, the risk and the profitability, and the chance of a shipment being rated along that lane, as I explained in the live stream, and I'll explain it later as well once we get into the actual more details about how the system is going to work. So it creates that, puts it in there, and we'll be able to access all the different routes to the target system wants to trade with just by looking up in this map. But that's the first one we have, 1-2. So then we say, okay, system 1 then has another gate to system 3, but it's a one-way gate, so we're going to ignore that gate. And then system 1 has a connection to system 4. At this point now, we recursively call the same function and change a couple things, pass through some different values, so that it will then look at the system that's looking at. So system 1 is going to be system 4. So now we're looping through system 4's gates and looking for the same conditions. So system 4 has a connection to system 2, so we create another trade lane, or trade route, with the lanes 1-4 and then 4-2. So 1-4 and 4-2, and put it in that map. And then we say, okay, system 4 has a connection to system 6, so we have to go there because the game doesn't know and we don't know. Now, we know from this graphic, but this graphic's assuming that the map's being generated the same way every time. It's not going to be. So in another version of this map, system 6 might connect to system 2 instead of system 4 connecting to 2, and 4 just connects to 6. So we have to go through each system individually and see if there's a connection or not, because you just don't know where a connection might be at. So we're looking at 6 now. System 6 has a connection to 5. We go to system 5. It's the third jump. Then system 5 has a connection to system 3. So we jump to there, which is jump 4. And system 3 has a connection to system 2, but again, we're already at 4 jumps, so we can't do that, so we ignore it. System 4 we ignore, as it's already part of the pathing. And so let me explain what the pathing is. The pathing is a way that I'm tracking the actual chain of systems leading up to when you find a match. So we start out in 1, so that gets added to the pathing vector. Then we move to system 4. System 4 gets added to the pathing vector. If at some point we end up back around within the current process, getting back to system 4, we can tell the code to ignore it because it's already been added to the pathing and we're not going to go back through that system. So it essentially prevents it from going back to that system. So we're not running into the situation where we have a loop where, you know, you're going like from 1 to 4 to 1 to 4 to 1 to 4 till back to 1 because we're going back and forth between that system. We don't want that to happen. And so we do that, goes through all those gates, stops, comes back to system 6, so we're back on jump 3, or 5 rather, and 5 now has a connection to system 9, so we go to there, it's jump 4, we check all those gates, yada yada yada, do all that. So at the end of the day, none of this ends up making a match. We have to check it because we just don't know. So then we come back out of system 6 and we go back to system 4. So system 4 has a connection to system 3, so we go there. System 3 has a connection to system 2, so we create another trade route with lanes 1 to 4, 1-4, 4-3, and 3-2. So now we have 3 trade routes. We have 3 trade routes for the system 2 target. 1-2, 1-4 to 4-2, and 1-4 to 4-3 to 3-2. So we ignore 4 because it's already part of the pathing, go back up to system 4, and we go to system 5, so that's jump 2. System 5, we're at jump 3. System 5 is connection to system 3, so we go there, it's jump 3. And we have another connection to system 2 created, so we create a new trade route for 1-4, 4-5, 5-3, 3-2, so this way. And as we're going back up into the previous systems, as we're completing these, we're actually popping off the last element from the vector so that we're freeing up the pathing. So, like in this case, in the pathing, we might already have 5, but we're coming back out to 6, so we're moving 5 from the pathing. From 6, we're coming back to 4, so we're moving 6 from the pathing. 4 is still in the pathing. Go back down to 3. 3 is added to the pathing. It's removed from the pathing. 4. We go to 5. System 5 is added to the pathing. Then System 3 is added to the pathing. And then we add System 2 to the pathing and then use that to create the trade route. And so once all of that is done, once we've gone through all the different connections and all the different combinations we can get to through for one system, which we're looking at for a trading partner, through all the jumps that we can do, we go back up to system 1 and say, okay, system 2 is done, go to the next gate, system 3. System 3 is not a target because system 3 cannot be a target because its gate is a one-way gate. So we skip it and we say go to 4. So I have to get rid of this too. So now system 4 is a target, and we repeat this exact same process for system 4. This time though, system 4 is our system we're going to be trading with. So the first region or lane route that'll be created is 1-4. Then we'll do 1-2, 2-4, 1-2, 2-3, 3-4, 1-2, 2-3, 3-5, 5-4, and so on. Let's see, 1, 2, 3, 4. So we couldn't go from 6 to 4. So in this case, that's all that we have. Is 1, 2, 3, and 4. There's only 4 routes to 4 that are valid. Now, once we're done with system 1, we move on to our next iteration. And so the iteration is just a fancy term using to differentiate the system level jumps from the universe level jumps from the system level jumps, which makes no sense anyway in the context of this too, which is why they're called iterations. So when you go to a new iteration, we are going to the systems connected to the originating system. So in this case, iteration 3 for this would be to go to system 2. Now from here we say, okay, what systems are at 2? So we have 1, which is already in the map, so we ignore it. 3, which is not in the map, so we set that as a target, and now we do the exact same thing that we did before. Except now we're using system 3 as a target. But and this is the only way you can really get to 3, since you can't do a connection here, since this is a one-way gate. But since we're going from 2, we're looking at 2 and we're saying, why is okay, that was weird. we're looking at 2 and seeing what's connected to 2, because we can go up to 4 jumps before, so like 1, 2, 3, 4. So this would be the furthest system away that we could trade with. That also means, though, that we have to consider that any system connected to these systems we could still be able to trade with. Or we have to consider, 6. 12 would be the furthest away. You can't go any further, so that would be like the dead end. But at 6, we still have systems we could theoretically trade with that we wouldn't have set up a route map for yet, because they're not directly connected to 1. So we have to kind of propagate through the chain of gates to figure out where everything is and what we can actually trade with. And that's where this thing just kind of blew my mind in terms of how complicated it was going to be. Because it's basically using a double recursive function, or using 2 recursive functions that are like calling each other. It's headache inducing, we'll put it that way. But yeah, so on iteration 2 now we have 3. So now we can get to 3 from 1, 2, 3, 1, 4, 3, 1, 2, 4, 5, 3, 1, 4, 5, 3, 1, 4, 6, 5, 3, 1, 2, 4, 6, 5, 3. Can't do because that's too many jumps. So again, you kind of have to do the exact same thing, but from each system. 4 is already in there, so we don't have to worry about that. So now we go to 3. From 3, we can see 2 and 4, which are both already in the map. So then we look at system 5, which is not in the map yet. So that becomes the target. And then we do the same thing. We process all the different ways we can get to system 5. And then from here, we so from system 3 we go to system 4. We're assuming that the gates are in numerical order in the vector. Gate 4 would be next. And from gate 4 we already have 3, 2, and 1 in our map, so we ignore them. 5 is already in the map, so we ignore it. 6 is not in the map, so we do that one. And then that's where we get this thing down here would be generated by that one. And then next we would go to 5. From 5, all these gates are already in the map, so we ignore them. 9 is not in the map yet, so we add 9 to the map through that process, and 7. We checked 6, 4 and 5 are in there. 12 is not, so we add 12 to the map and process all the ways to get there. And at that point, we're done, because we can't go any further than 12, 9, or 17. Or 7, rather. 1, 2, 3, 4, well, 17, I guess, yeah. So 1, 2, 3, 1, 2, 3, 1, 2. Oh no, we can go to 19 and 24 as well. But those would be the endpoints at that point. And so would 13, I think. We can't do one through here, so 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so 13 would be the endpoint here. So I actually think the original one I had for this is wrong. Oh, shut up. Need to fix this. Okay. So this way. Okay, boom. So this would be, after everything is said and done and all this craziness is over, this would be the trade region for a planet in System 1 that is a Type 3 planet. This would be the these would be the very outer systems that it could trade with, and we'd have a map of all these systems with all the different routes to get to those systems. Now, 1, 2, 3. So yeah, for these, the only way you can do it is through 1, 4, 6, 12, then 24 and 19. You couldn't go 19, 24. It's the 5th jump. At a certain distance, you start getting less and less. Well, it's not really true, because if there's a lot of different connections between these, you could get a lot more. The only reason these are kind of insane is because they're all freaking connected to each other. Now, I did that on purpose. I wanted to have something that was like crazy like this that would all be connected together. So it forced me to think about that possibility, as well as having systems that were in this kind of formation with a one-way gate or an inactive gate. So let's go ahead and actually talk about the code now. Now that you have the kind of sort of understand the theory behind it, we can kind of go into the code, which won't make too much sense at the moment because I'm still I haven't actually run this or tested it yet because it's not completed yet, so I don't know if it actually works or not. But the idea is that we call this getTargetSystem. GetTargetSystem takes three parameters. The current system that we're looking at from process trade regions, the current jump, which is passed through from here initially, and the maximum number of jumps, which is dependent on the type of the planet. So in this case, it'd be 3 for the or 4 for the type 3 planet. And then we're calling this and passing it through. For pathing, we're pushing back the name of the current system, so system 1 in this case. And then we're looking at the gates for system 1. So if the current jump, so this is like simulating the iteration here. So if the current jump is less than jumps, so in other words, if the iteration we're on is less than, so it should be less than or equal to. It should probably be less than or equal to. Less than or equal to 4. Well, no, because we're using a 0 as a starting point. This is 0 indexed. Kind of. Sort of. I use 0 indexed when it's not really an index, but we're starting on 0 as that being iteration 1. So as long as we are less than jumps, we're processing this. We check our trade region, temporary trade region map for the string name of the current gate that we're looking at. And if it's not there, then we are checking if that gate is an active gate. If it is, then we are setting that gate as a target, or that system as a target system. And we're calling develop trade region on the current system. This probably isn't actually right. It should be current jump. And this should be jumps. And so we're calling this one. Now this one is another recursive function. This one takes the same things as this because we're basically passing them through after setting the target system. So what this one does is what I was explaining before, as far as how we're going through each gate and going through those gates, going through the gates into those ones, the ones into those ones, until we hit the maximum number of jumps. So again, we now have, so we're passing through current system, and this is essentially simulating, not simulating, but is allowing us to get the first connections. So like the 1-2 connection. So we're cycling through system 1's gates. We're using find on pathing, so we're checking to see if the current gates, the destination of the current gate is already a system inside of the pathing vector. If it is not, then we're continuing. If it is, we're skipping it. So if it's not in the pathing yet, continue. If that gate type is active, continue. And then we're checking if the gate destination, so the system that it goes to, is the target system. If it is the target system, we're creating a new trade route. And then we are this probably shouldn't be here either. This should probably be before this loop runs, because the trade route is going to be the origin, the starting system, and the target system. So that probably needs to go somewhere else. I'll make a note there. Start sys and target sys. So we are pushing the next gate, in other words, the gate we're looking at's destination into the pathing, And then we're iterating through the pathing vector and basically updating this paths trade lane vector by passing through the current and the next element. So the first element of pathing would be system 1, then the second element would be system 2. And then we are creating a trade lane between those two to simulate the 1-2 trade lane, and then pushing that back into paths. And then we take that paths and update it into the temporary trade route we're creating with create trade route, and pushing the paths into there for that particular route. And then we are pushing that trade route back into routes, which is a vector of trade routes, which is those objects that will be in the vector that's part of the vector, which is the value of the map. So, like, I'll show you the map here. Well, where is the map? I made it global, I think. Yeah, so the map is a string, key, and a vector trade routes, a vector of trade routes value. And then we pop off the target system gate, target system from there, because we don't want to use it anymore. And then we go to the next gate. So let's say the next gate is gate 3, because we're going to go sequentially with this. So first of all, we check the pathing. Pathing 3 is not in there. Check the gate. The gate type for that is going to be one way, so this will fail, and we'll just skip it and go to gate 4. So gate 4 is not in the pathing. The gate is an active gate. And the system 4 is not the target system, so we go to this else, where we recursively call this same function, but we pass through the next system, which is system 4, called get system, which returns a planetary system object. That basically returns the planet 4 system object. We pass through current jump plus 1, so we say, okay, we're on jump, essentially effectively jump 2 now. And then we pass through jumps as it is, because that's the maximum number of jumps, and we start again. So we come back up here, and we say, okay, for each gate in current PLSys, though, is now system 4. So system 4 has, system 4's first gate is to system 1. So we check the pathing, and wouldn't you know, system 1's already in the pathing, so it fails this check and skips. Next gate is system 2. System 2 is not in the pathing. The gate is an active gate, and the target system is system 2. So we create a new trade route. We already created the trade route before. We create a new pathing by pushing back. We push back the system 2 to the pathing vector, and then we process that to make the trade paths for the paths vector. In this case, though, it's going to be system 1 and 4, system 4 and 2. And then that'll get pushed back into the trade route object, and then that will be pushed back into routes for this particular system. And eventually these will also be cleared once we get to a certain point in the code. I haven't actually gotten that far and figured out where they should actually be at yet. The clear is to remove stuff from the previous routes and things like that. Then we pop back the system 2. And then we go to the next gate, which is system 3, I believe. Where's my... Yeah, system 3. So system 3's gate meets all this stuff. It's not in the pathing yet. It's active. That's not target system. So then we run this code again. This time the system we're passing through to this function is system 3. Current jump plus 1. So it was 2. Now it was 1. Now it's 2, but that's really 3. And the jumps is the same. So we run through this whole process again. And this time we have another one for 2. So we create a new trade route with that, and then we check the other gates. 4 is already in the pathing, so we ignore it, and then we see 5, so we go to 5. And once we get down to 5, we're on jump 4. So at this point, we don't go to any other system because we're already at our maximum number of systems. So we jump back to 3, Then we jump back to 4. And then from system 4, we have two other gates. We have 5 and 6. So we go through that same process for these gates as well. And that builds our list of routes that are valid. And then it also kind of shows you how the code will go through and parse out all the crap that's not valid. It's really, really complicated. And recursively calling functions is this is difficult. And it's easy to recursively call a function when the function's kind of simple. This is pretty complicated. So you have to write the code in such a way that you could do whatever number of calls to it and it would still process the same way and still be able to be called again and still process the way you want it to. It took me a while to kind of get my head around how the hell to actually write this thing to do that. And this code up here still, I don't think is actually still there yet. I think it's still a little bit too, it's a little bit too bulky, I think. I'm not sure if we need this or not. That's really hard to figure out what you do and don't need and what stuff does when you can't run it yet because it's not complete. That's the most annoying part of this is that if I could run it and see what's not working, I can then say, okay, this isn't working and figure out why that's not working and then fix it. In this case, I can't do that yet because I haven't actually completed the entire logic to make the thing work at all. So I have to wait till I get all that done, then say, okay, this part doesn't work. How can we fix it, or does it need to be moved somewhere else, or what have you? So what this second part does now, so once all that's done, we come back out to here, because the first call to this will then eventually finish, because all the subsequent calls will finish and kind of it'll backtrace through the calls back to the first time that function was called, and then that'll finish. And we'll take the routes vector, which now has a bunch of stuff in it for the target system, and we will take that target system, make a pair with them, and insert them into the map. And then we will call the next system, and then if it's not in the map yet, we will create that as a target and run through that again. So again, saying the target is system 4 instead of system 2 now. Then we run through all that again. Now what this is supposed to do is it's supposed to then start doing the jumps into the new systems. So once all this is done for one system, we then call this to go to system 2 to then run system 2 as the current PL system and then run all this again for system 2. That gets done. We go through the gates for system 2. We do those, then we do the gates for the next system, and so on and so on, and then we just kind of come back through those, go to the next one, come back through them, go to the next one, and it's basically we're recursively calling two functions at the same time, sort of. It's just I have no clue if it's going to work or not, but it's going to be a hell of a thing to see whatever happens. I mean, it might end up blue screening of death my computer, which would still be pretty interesting and awesome to see. But we'll have to see what happens when I actually get it functional. So that's what I've been breaking my brain over the last week and a half is this stuff. It's crazy stuff. Now, this isn't even the hardest, well, maybe it's the second hardest thing to kind of conceptualize about this. So let's talk about what this economic system will eventually actually do. I want to come back to this because it's easier to use this to kind of explain than looking at code. So let's say that we have let's just say we have a resource called resource because let's keep it a little bit more simple. And we have Zarn, what the planet will use to pay for that resource. And we'll just say that this resource is like a magical resource that does everything for the planet, and there's no other resources that they have. There's no food or water or anything like that. It's just resource. And the population will use a certain amount of number of resource every turn or every unit of time you want to use. In this case, we're going to use turn because it's going to be going into the text version of the game, which is turn-based, not time-based. And we're going to say that for every turn, a planet will use a certain amount of resource based on the population, and that will create a demand for the resource that then will force the planet to then trade another planet for the resource with Zarn. So essentially buy it from another planet and have it come back to them. So let's say we have this planet in System 1, We'll say it's just that type 3 planet. We'll say it has like let's just say 100 population, and this won't be actually how it will process, but this is an example of how it will work. We'll say that for every person, the planet produces. I'll just say the planet produces. Okay, for every 10 people, the planet produces 5 resources every turn, and the population, each unit of population will consume. Rather, every 3 units of population will consume 1 resource. So, in this case, this planet is kind of self-sufficient for the moment, because they're producing more resources than are being consumed per turn. Let's see, for every 10, 1 resource. Let me write this down so I can actually, because it's like, this is kind of hard to keep track of. So, let's, so for every, Everett, damn you, why, where are you? Every 10 units of pop, we generate 5 units of resource. For every 3 units of pop, we consume 1 unit of resource. So yeah, we are producing more resources than we're consuming here. But what'll happen now is that for every turn where we have more resource than pop times 5, we'll say, we're going to increase the population by, let's say, 30. So if we have 100, so let's like map this out. So if we have 100 population, every 10 units of population creates 5 units of resource. So there are 10 units of population and 100. So 10 times 5 is 50. So we are creating 50 units of resources per turn. And on the first turn, since we have 3 units per pop to use the resources, it's not going to be exact. It's like 33.3 or something like that. Or 3.03. We'll say 3. Even out to 3. So, oh, I don't know what I'm doing. 100 divided by 3. 33.3, there we go. So 33.3 resources, or well, rather, 100 divided by 3 equals 33. So plus 50 resource per turn minus 30 resource per turn. And so we get, ends up with 17. So we have a plus 17 resource per turn surplus. Now, what we're saying is that for every turn where we have 500 resources or more, so let's say that we start with 0 resources, so we have 17 in the first turn. How many turns will it take to get to 500? So I don't have to map it out. I think we're still recording. We can get rid of this for now. Yeah. So 29.4 turns. So on turn 29, on turn 30, we'll say. Well, I'll say 31. So on turn 31, we will have about 500 resource. At this point in time, we'll increase the population by 30. So population goes up to 130. So now we have to, now at this point we have to recalculate all this. This is like the long way of explaining how this is going to work, but it kind of makes more sense this way. To kind of just walk through and see how this will start, how the economic system will actually fundamentally work. So 130, so if we look at this, this would actually end up causing it to never actually become less, because we're producing more every turn than we're taking in. Let's change this to 10 resources. No, because that still wouldn't work, because now we'll have less than it. So let's do 100 divided by 10 times 2.5. I'll modify it a bit and add a little more variability here. So that's 10 times 2.5. I think it's 20 point something. Let's see. Maybe 21. 25. Okay, 25 times 5, so that's actually 100. So we'll say times 2. Which still comes out to 50. But this will be just a direct thing here. So let's see how that affects this. So now we have 130 divided by 10 times 2.5. Times 2. So 130 divided by 10 is going to be 13. 13 times 2.5 is like 40 something. 32.5. Then that. Oh crap! I've been starting and stopping the. I gotta stop using the number pad when I'm using this when I'm recording. Okay, so I think we still have a situation where we have just an exponentially ever expanding amount of resources here. So 16 times 2.5 is 40, times 2 is 80. So what is the other one though? So then it's 160 divided by 3. Yeah, so we still have that same problem. So we need to... What if we yeah, so, and this is kind of the problem with this, trying to figure out the formulas to make this work properly. It's probably just some way of increasing the population. Maybe instead of 30, we say by 60. And instead of 1, it's going to be 2. Or instead of... yeah, every 3 will, every 5 units of pop will use 1 unit of resource. Or rather, every 2. We want to do more, not less. So what if we have these conditions? And we go to 160. Or wait, let's see. There's one thing we didn't calculate before, which is this. So, we'll have 150 resources at that point. And, 5,500 resources. Then we'll go to 130. So now 130 times... Almost did it. 130 times, what do we say, 5? 650. Okay, so then we're using resources, but we're not increasing the population. We're still increasing. So yeah, it's this is kind of what's going to happen eventually. Somehow, I'll figure out a way that we'll have it so that every turn will consume resources and create resources, and after a certain amount of time, once we have more resources than a certain number of resources, the population will expand, and then the rate at which resources decrease will increase. And this will actually be, this is like really too simplistic for this. What needs to be in account here is that it's not really every unit of population will not produce resources. It's every adult population. So the population will be broken down into children, adults, and seniors. The adults will be working, part of the working population, so they will produce resources, whereas the children and seniors will only consume them. And they'll consume them at a greater amount. So kids will consume 3 resources, and elders will consume 2 resources. Adults consume 1 resource. And that's kind of how the system works. So it's more complicated than what I'm showing here, and it would actually work if we did that with this. But I'm not going to go into that level of detail with this. This is kind of showing for an example of how this would work. So as that's going on, once we reach a point where the number of resources becomes 0, or becomes a number that becomes an amount that when they go to consume the resources for a turn, they end up having 0 or a negative amount of resources, then the next turn, population will start to enter a kind of, I'll use starvation in terms of like Civ, a starvation phase, where if after a certain number of turns they don't get the resources they need to consume, they'll actually die off, and you'll have a population start decreasing. Before that, or while that's starting to happen, though, there'll be a demand created for that resource, and the planet will say, okay, I have these systems in my trading region. Let's bring this back up. I have these systems in my trading region. For like system 1 here. Whoops, 1. Oh, 1, there. I have these systems in my trading region. I need to trade for a resource so that my population doesn't die off. I need to find the system that has... one, has the resource I'm looking for that they're selling it. 2, that I can buy the resource from them, so I have enough Zarin to buy it from that system, or a planet in that system. 3, that I then want to say, of the systems that meet those requirements, I want to find the system where the price is the lowest. 4, of the remaining systems that meet those requirements, I want to find the system that is that has the closest, that has the lowest, or rather, I want to like arrange the systems from least risky to most risky. And then once those have been identified, I want to find the however many lowest risk systems that are closest to me that still meet the other conditions. And so based on an algorithm that will determine all that, the system will then create a trade request with the other system. They'll send the payment to that system, and that system will send back the resource that they're trading for. Now, on both directions, there will be calculations going on each jump of the trip, depending on how many jumps there are. So, if it's just between system 1 and 2 on this trade line only, then it's only going to be a one-time calculation. But if we're going to system 6 through 146, each jump there'll be a calculation done to determine whether or not part or all of the shipment going either way is raided and stolen by pirates, which will be determined by the riskiness of the route and another variable, which is the chance of the raid chance, which is based off of the number of recently spotted pirate ships in these systems. And so every time, so along this route here, how many pirate ships have been seen in System 1 and 4 will determine how likely it is your ship's going to get, the trade ship's going to be raided along this trade route. And the same thing for 4 to 6 along that trade route. And the same thing with the shipment coming back. So it's possible that the planet will send out a payment. It gets that system, and that system sends the trade resource back, and the shipment gets raided on the way back, or the payment gets raided on the way there. Either way, the system that is initiating the trade gets kind of screwed, and has to then wait until they have the amount to do the payment with, and then go through that process to figure out which system is the best one to trade with, because at that point, maybe System 6 has traded their stuff to some other system. Or figure out some other system to trade with. And while that's happening now, the population's starting to die off because they haven't gotten the trade back yet. They haven't gotten the resources they need yet. At a certain point, though, the population die-off will then exceed the amount, will drop the population below what is to the point to where the amount of resources consumed is being outpaced by the resources being produced again. And so they'll start regrowing on the population. And that's kind of how the system will work. At least the proof of concept of it. And that's pretty much how I want the system to work for the system that'll go into the game proper will work like that too. But yeah, so this part of creating the trade regions is pretty complicated, but then there's another layer of frigging complication on top of that that has to deal with all that stuff. So it's just, there's no way I'm going to get this done by this update. So which is why I wanted to do this and just show you the code and explain what the system does and how it works. I am going to, though, however, do one last thing, which is I am going to show you what I have so far on that. Which one do we want? This one. On that track. I've gotten more done. I'm going to go and mute the microphone because if we don't, it's going to pick up the microphone and we'll have this echoey thing in the recorded video. So that's why they won't hear anything from the microphone for the rest of this time when this is going on. Really quick, this is what I was talking about. There's supposed to be more stuff in here that connects these two parts together, but I haven't gotten that done yet, which is what I'm hoping to get done so I don't have this space here. And there's a lot of other instruments that are going to go into this too. This is just the basic kind of melody that I've mapped out and created for this. There'll be like percussion and other things that are going on in the background as well. And there's still a little bit of work to do on fixing the some of the speed between some of the notes. There's still some. It still sounds a little bit weird in some places because it's the notes are not spaced correctly, so that it sounds faster or slower than I want it to sound. That's pretty much this is pretty much what it is going to be, minus some maybe extra flourishes once I get a little bit further along. And I think I'll just let the microphone stay on while we're waiting for this to load. Okay, it's loaded. Never mind. Microphone off. So you kind of get an idea of what the sound of it is. Like I said, it's kind of like an Irish sort of melody to it. And there's a lot. This is like just 3 instruments out of a bunch that are going to be in here. And we kind of see all this stuff over here. So eventually all this stuff will have stuff in there. And actually, I think some of it is done, but isn't done over here, I think. Bass recorder, that's this part. Or that's this part. String bass, piccolo, winds. Okay, that's vocals, not winds. Okay, I guess I hadn't actually done anything yet with some of the stuff. It's like gamelan here. So that's more like maybe some sort of bell instrument. One thing I noticed that with my set of east-west stuff, or east-west, what is it? East-west? East-west, yeah. I was thinking Westwood for a second. I thought I was like, wait, East-West isn't it made Command & Conquer? No, it's Westwood. But east-west stuff is that there's no harps in the strings or anything like that, which is annoying. So having to go through and try and find something that's like a harp kind of sound to it, or so maybe some sort of ethnic instrument that's kind of like a harp to fill in some of this stuff. But yeah, there's going to be a lot of other things in the background. Like, for example, the vocals here. Let me turn that on. I think that's probably going to either play below during this or during this part. Probably during this part. It seems like it'd be more of a fit in this kind of a pattern. But yeah, so there's stuff here, there's stuff here. There's stuff that happens after this. It's going to be probably about a 2.5 or 3 minute song. That's going to be used for a specific scene in the game. But yeah, that's where it's at now from where it was during the live stream. I think during the live stream it wasn't this complete. I might be thinking of one of the other recorded developers log videos, so. But yeah, so that's going to be it for this developers vlog video. There may be some more stuff that I'll do in terms of like no, I think this will be the last developers vlog video for this developers vlog, because anything else that happens after this point will have its own video and it'll be on the update. So, thanks for watching all these. If you did, tend to go a little bit long-winded on these, but that's kind of what the point of a developer's vlog is. It's a kind of vlog about what's going on with the development. So that's what I do, to a great extent. The next update will be happening in next January, because like I said, I'm doing a year-long update, year-long waits between the updates now, because I think that will give me enough time to actually make progress that's worthy of making an update for, instead of like trying to cram a bunch of stuff into like a 6-month update. Mainly because even with the 6-month update, I was still finding that I was working on it a little bit, and then like once it came up to like the end of it, I was trying to rush to get more stuff done, because it just wasn't really enough time for me with my the time that I have to work on stuff like this to get a lot done. But we'll see how this works. So be on the lookout for some other introductory or lore videos. I might actually get the lore series up and running finally. I don't know if I think I mentioned it before in some of the other videos, but not in the maybe in the developer's lore, but not in the context of what those actually are. So there's actually going to be a series of like interactive videos on YouTube where you'll be able to it'll be kind of like the Mass Effect Codex almost, sort of, except with YouTube. So actually, I don't know if that'll work now because, well, maybe it'll work, but I'll see how it would work because YouTube has removed annotations now. So maybe it won't work that way that I expected to. Maybe it'll just be a thing where it'll be a topic and it'll look like you're selecting things going through a menu or something. But you'll essentially have a narrator, which will be me. But it'll be like the voice will be more to sound like a robot or something, some sort of like AI or something. And you'll go through and it'll talk about different aspects of the lore that you can select. Like you can like look up stuff on the history of like the Sluicon, SLU, or the Visar or whatever, and different corporations, historical events, all that kind of stuff. So, like all the stuff that's on the website, and some of the stuff that's not on the website, but it's on the wiki, all that kind of stuff will get put into video form eventually. Now, what it'll be like in terms of like the visuals being displayed, who knows? Probably won't be much visual. Maybe it'll just like scrolling text or something for now. And eventually, maybe once the game gets made, the actual full game and the engine gets made, start putting in stuff like images of ships and things, or characters or whatnot. Yeah, so be on the lookout for that stuff and more introductory videos. I'm planning to get those going again. That kind of fell by the wayside, and I haven't really done anything with those for a while. But be on the lookout for all that stuff, and I will see you for the next developers vlog.